Hello. In today's video, we will discuss the environment of a Unix process. With respect to this, we are discussing the sub-contents are introduction, process termination, command line arguments, environment list, memory layout of C program, memory allocation, environment variables, set jump and long jump functions, get rlimit, set rlimit functions, then Unix kernel support for processes. First, introduction. As we know that a process is a program under execution in Unix or POSIX system. That means any program we are executing, the executing program is nothing but a process. That we need to understand. And whenever the program is nothing but it is started with the main function, as we know that the set of instructions that is collectively represented under main function, what we can call as a one program, especially C program. So as we know that a C program start execution with the function called main, and the prototype for the main function is int main int argc, then character of argument vector. In this case, where argc is the number of command line arguments and argv is an array of pointers to the arguments, which means that the argument count will show the total number of arguments we are passing in the command line. Argument v is nothing but it is a pointer to the corresponding argument list. When a C program is executed by the kernel by one of the exec function, a special sort of routine is called before the main function is called, which means that whenever in Unix environment a program start executing by calling the exec as one of the API. We'll discuss shortly what is the use of that exec API. Okay, when we call that exec API, the program start executing, but before start executing the main function of that program, a startup function will be called. Okay, that we need to understand here. Next, the executable program file specifies this routine as the starting address for the program. This is set by the link editor when it is invoked by the C compiler. What we call as a startup routine, yes, it will be taken in the starting address for the program. Means before the main function there is one routine has been called, that itself is a starting address. Next, this startup routine takes the values from the kernel and command line arguments and the environment, set things up to that the main function is called. Means that startup routine will take the different types of the values from kernel, command line arguments and environment. We'll discuss shortly what you mean by environment here. When login into the system, the set of environment will be set at the environment with the different variables. That is what I can call as an environment variables. We'll discuss shortly. Next, process termination. As we know that a program under execution is nothing but process. That means the process will be started due to main function. Now, how a particular process is terminated? Nothing but program can be terminated. Here, there are different ways. Basically, we are having the two ways. One is normal termination and one more is abnormal termination. In normal termination, we can done 5 ways. For abnormal termination, we can do in 3 ways. So the first point in normal termination, return from main, calling exit, calling underscore exit, calling r underscore exit, that is capital, return from last thread from its start routine, calling pthread underscore exit from the last thread here. Here the first point that is return from main. So that indicates you might be observed some of the things when you are doing the C programming lab in first sem. If I not included the return of 0, then what kind of the warning message as I'm getting there? So as I'm getting the warning message is that with no return value. So that means either I should include void of main, or I should include the one statement in the program is return of 0. Okay, that means it is a proper termination of the program. Otherwise we'll get the warning message. That is the first one, written from the main. Then calling exit. In some other programs we might be observed that exit of 0 mean if we executed all the instructions as per the program requirement, at the end we are calling the exit function to terminate the program. Okay. Next, calling underscore exit. It is similar to the exit, but we have some minor differences there. The exit function will make some cleanup process for returning all the resources held by that particular program, but underscore exit will not do any kind of the cleanup process. Just it is returning immediately to the kernel. Okay, we'll see shortly that there is one block diagram with related to that. Next, return of the last thread from its start routine means, as we need to understand what do you mean by thread. The big program has been divided into small routine function, each in it a routine what I can call as a thread. Okay, so the one thread of that program is returned values in the startup routine, what I can call before calling the main function. There is one function has been called, that is the startup routine. Okay, due to that also we can terminate the program. Calling p thread, there is a process thread exactly. This is one more concept added in the textbook. There is a process thread also they can terminate. Means if anybody is terminated the program after execution, then the one of the terminating thread will terminate the program. Next, abnormal termination. I hope you got the term. Abnormal termination means it is a forceful termination here. Here the process still may be sometime executing or sometime verge of completion. Okay, so here there is no normal termination, it is what I can call. So either we are calling abort or by sending the signal, especially kill signal. Okay, so using that we can do it all the things. We can do all the things. We can do it all the things. Next, receipt of the signal, that's what is the kill. Response of the last thread of a cancellation request means sometime what happened, a particular thread is executing the program. Suddenly we thought that we terminate thread itself. So in that case the corresponding program is also terminated. Only we need to keep in mind, normal termination is nothing but everything is perfect. Abnormal termination is nothing but we are forcefully terminating the program. Exit function. Three functions terminate program normally. That's what underscore exit, underscore capital exit, which return to the kernel immediately, as I already highlighted that point, and exit which performs certain cleanup processing and then returns to the kernel. And one observation we can make it, all the three functions will take the one argument that is of type integer, like we are passing the 0 value here. All three exit function expect the single integer argument called the exit status, means that will be the return value with respect to the exit status. Returning an integer value from the main function is equivalent to calling the exit with the same value here. Okay, that means the exit function is returning the 0 value to the main function. Thus, exit of 0 is same as return of 0 from the main function. So either in the program we can include return of 0 or we can include the exit of 0. In the following situation, the exit status of the process is undefined. Means any of these function is called without an exit status. Means main function is called without any exit function. Then main does a return without a return value, means we are not passing the return function. If the exit status of the process is undefined, means that value is not at all related, that value if I passed, in that case also the problem is arising here. Then one function, that is at exit function, here we can register up to 32 functions that are automatically called by the exit. These are called exit handlers and are registered by the calling the at exit function. So this is the prototype for that function at exit. So it will be 0 if it is successful, non-zero on error. The declaration, what it says, that we pass the address of the function as the argument to the at exit, means what are the functions we are using in the program, those functions will be written by using at exit. When this function is called, it is not passed any argument and not expected to return a value here. The exit function calls these functions in reverse order of their registration. Each function is called as many times as it was registered, means these functions will be called in reverse order. Shortly we will know that example, let you know the output. This is the simple program what I taken there. I am registering by using the one function called myExit2 by using at exit function. If it is failure, this error statement is executed. Again there is one more at exit, exit of 1. If it is a failure, then this statement is executed. Next, at myExit1, again as we registered. So this way we call the functions. But related to this, there is a two user defined functions are there. Just we can find it, myExit1 and myExit2. So what we are getting the output, that is important. If I run this program, first statement to be executed, main is done, because as I told, the registration will started from this point, myExit2, next myExit1, myExit2, then printf. But while executing, it will take reverse order. Reverse order means just like stack, last in first out. Okay, the last function to be registered is printf in this context. So main is done. Just we can observe the output here. Main is done. Next, first exit handler, second exit handler. Just check it in the output here. Okay, what is the next one? Exit 1. Next one, exit 1. So this, due to these two, we are getting the first exit handler 2 times, then exit handler 1 time here. Okay, I hope you got the point. This is what we can call as an at exit function. This is the block diagram with respect to the process termination. Just we can make the observation. The program start here by calling the exit function. Then C startup routine has been called. Then main function has been called. Under the main function, we are calling the different user functions. The user function may contain the exit function. So that exit function is again returning status to the kernel here. Then one thing what we need to understand with respect to the exit function is that here every time they are calling the exit handler, nothing but we are calling the at exit function. These here, call and return, when we registered, when we are returning the values here. So this entire dotted line what I am showing here, it is a one user defined process here. User defined process, nothing but when you are executing a small C program, these are the things has been taken place in the back end of that particular operating system. But ultimately what we need to observe is that it is managed by the one component, that is what I can call as a kernel here. Okay, just we can make the observation as I told. We can terminate either by using underscore exit or capital exit or normal exit here. But ultimate thing is that we are terminating the process here. The one thing you keep in mind, when I call the exit function, there is some cleanup process will be taken place. Just we can find it here. In turn, it will call the underscore exit. Okay, that you keep in mind here. There are some more points with related to this we'll discuss in the next video. Thank you.